welcome to the Cosmic Lounge live on Ustream from NASA's Jet Propulsion Laboratory. I'm Ye Hill, and today's topic on this webcast, freeing spirit. The Mars rover has been stuck in, up to its hubcaps basically, in soil, very loose soil on Mars, and the team down here on Earth has been trying to figure out a way to get the rover out of its predicament. With me right now is the project manager, John Callas, and he's going to fill us in on details on what exactly the team is doing. First of all, John, set the scene. What happened to Spirit to get it into this predicament?
Well, about 2 months ago, Spirit was driving around the west side of this feature on Mars we called home plate. It was heading to a location to the south to get set up for the winter, and it began to bog down in loose soil. Spirit is the rover that has only 5 operating wheels, so we drag that 6th wheel. So we have, degraded mobility over the other rover Opportunity.
So to help viewers see exactly where Spirit is, we have a photograph that Spirit took itself, right?
That's right. We have some imagery that we took of the surface, and it's a panorama. Well, this is a front has-cam image that shows the embedding, and you can see on the left side of the screen there, you can see the left front wheel, and you can see that it's buried down to its hubcap. And notice the light, loose material that's around it. The other 5 wheels are also buried like this. So this is the worst embedding event that either rover has seen in their 5 years on Mars. And it's particularly bad because it's a 5-wheeled rover now. It's tilted slightly to the left, and there's even some rocks underneath that are complicating the problem.
So what exactly was Spirit doing at the time it got stuck?
Well, it was driving, and it started to bog down. And we continued to drive it a few more sols, and things just got worse and worse. And finally we said, well, wait a minute, this is not going the right way. And we stopped, and we took a careful look at how serious the situation was, and we decided at that point, before we do anything more on Mars, we better recreate this here on Earth, test it out, and decide what's the best thing to try for Spirit.
So we have videotape of exactly that, the test bed that we've created. We basically are recreating Mars right here on Earth, right?
That's right. I mean, the rover is stuck. We can't call AAA, so we have to bring Mars down to Earth. And what you see here is the preparation of the material that we use to simulate Mars. What we want to do is create a little bit of Martian landscape in our test facility. So we needed some special material. First we had to figure out what kind of material, then we had to mix it, and we have 5,400 pounds of that material. So there was a lot of mixing. It's gritty, dirty, hard labor to put this together. We had to mix barrel after barrel of it and then pour it into our sandbox. And you can see here, and then we had to rake and groom it, landscape it, just like the terrain on Mars, so it has the right slope. Here we're compacting the soil so it exhibits the right physical properties that we observe on Mars. And then once it's ready, once we have the special form set up, then we have to make sure that we have enough of it, that it's deep enough. And then once it's all set, we drive our test rover, which is just like the real rover, drive our test rover into this and begin what we call the extraction testing. Begin to experiment with what motions will work best. And you can see that even in this short amount of driving, that the wheels cake up, that the wheels sink in. So it's very, very difficult material. It's almost like flour. And so it has very little bearing strength, very little ability to support the rover.
Now, I wanted to at least talk about the fact that we originally had promised to go live from the test bed, and I know many of the viewers expected that, but what happened was there was no testing today, correct?
That's right. We completed a whole series of tests, and we decided we need to change the test to make it more Mars-like. And so we're in the process of deciding what that new change would be, and it turns out it's going to be some new material we need to put in, and we need time to develop that material, put it into the sandbox, and put the rover back in. So it'll be a couple days before our test rover is back in, testing a new set of things in new conditions.
So we really didn't have anything to show anyone from the test bed, and we weren't able to roll tape from a remote location, so we brought it back to the Cosmic Lounge, and we can show you at least clips of what's been going on so far with Spirit. Okay, so I have to say, we have been inundated with questions. I have a list of questions that were emailed to us. We have questions from Facebook and Twitter, and we, of course, have the Ustream questions. And let's just go ahead and get started.
All right.
Okay, first question is, am I right that the Spirit was the rover with the completely stuck right foot front wheel?
That's right. About 3 years ago, the right front wheel stopped working. It doesn't freely spin, and that's been one of the complications with driving Spirit, and that's what makes this particular embedding so difficult, because we now only have 5 wheels to try to get us out.
Another question, how many people are involved with this rescue effort?
Well, everyone on the project, which includes a couple of hundred people, are worried and are participating in this effort. But at any given day, we have only about a dozen people that are actively working on the recovery effort.
What's interesting, and this is an aside, when I go down to the test bed, it's interesting because you get to see all sorts of people on the team, different members of the team, the rover drivers. Everybody seems to come out of the woodwork whenever one of the rovers is in trouble.
That's right. Everyone from scientists to engineers, from technicians to management are all helping out and doing gritty, hard work down in the test bed.
And putting on the suits.
That's right, getting hot and sweaty and dirty.
All right. How many times per day are commands sent to Spirit, and do all commands originate from JPL?
We command each rover every single day. So we operate, actually the rovers operate on Mars time, which is just about 40 minutes longer than an Earth day. So typically each day we send a set of commands to Spirit, and yes, all commands originate here at JPL.
We're going to talk a little bit about that because Ashley Stroupe is one of the rover drivers, and so she's one of the programmers, and she'll be here in the second half hour telling us exactly how they operate the rovers on Mars, how do they send the commands, how do they plan the duties of the rover for the next day. And we'll be doing that in the second half hour. One more question from Ustream, from Russ Plays Guitar. Can 2 of the wheels be lifted?
No, the rover has a passive suspension system. So we can't lift a wheel, we can't move them out of the way. The only thing we can do is we can steer the front wheels and the rear wheels and then drive the 5 operating wheels. So that's the limit of what we can work with to get the rover out.
Because the point that Russ was trying to make was he thought that that might give more weight to the other wheels to create better traction. Is there a way to give better traction?
Well, that certainly is one of the issues that we want to try to maximize, is to get traction to the wheels. But there's really not a way we can shift the weight of the rover around. It is tilted to the side. One of the techniques we might try to do is to try to aggressively turn the rover, which might shift the tilt of the rover a little bit, changing the distribution of the weight. But there's nothing actively we can do on the rover itself. You know, it isn't like we can take, you know, all the newspapers out of the trunk of your car to lighten the load or to increase the load. Okay,
Mike the guy wants to know, why not misuse the camera arm to leverage the rover a little bit, since it was able to look beneath the rover? The arm.
Well, we do have a robotic arm on the rover, and it's about the size of your own arm, and it has the same level of dexterity, but it doesn't have much strength to it. About the most we can push with that arm is about 60 newtons. So it's about 14 pounds. And our rover weighs about 150 pounds on the surface of Mars. So it's really not a viable technique. We're going to exhaust all the conventional things that we can do with the rover to try to get it out before we have to consider anything exotic.
Does Spirit have the ability to tilt itself, to lean into the slope?
No, not really. Not much moves on the rover, so there's not really a way to distribute the weight. And it's really all about spinning the wheels and turning the wheels.
Are you able to modify its center of gravity?
No.
Okay. Let's see. Let's go ahead and give equal time now to the Facebook people. When my car got stuck in the sand, I reduced the tire pressure enough to drive it out. Is there something that you could do here? And this is from Omer Divers.
Well, the rover has solid wheels. They're made out of a single cast of aluminum, so there's nothing we can change on the wheels. But it's important to remember that on Mars, the embedding is very, very different from here on Earth, where you might get your car stuck in the mud or the snow. One of the reasons it's very dry on Mars, so water doesn't play a role here, or moisture doesn't play a role in affecting the nature of the soil that we're currently stuck.
You know, I sometimes answer some of the questions on YouTube. We post our videos on YouTube, and people are forever sending in suggestions. A few people have asked about the tread on the rover wheels, that if we had a different tread, that would have made a difference?
Well, it's possible that a different tread would make a difference. Remember, the rovers have been driving beautifully when they had all 6 wheels operating, and they were only designed to drive 1 kilometer on Mars, about 6/10 of a mile, and yet Spirit has driven 7 kilometers and Opportunity has driven 17 kilometers. So they've done really, really well, exceeding all expectations. But also the design of the tread on the wheel was also a compromise between safely getting off the lander and being able to drive over our airbags that took us safely to the surface of Mars, as well as to drive on the surface of Mars. So if we had too aggressive a tread, we might have gotten tangled in our own airbags and never have gotten off the lander.
So it was just differing priorities.
Well, it's something we have to balance, all the requirements for the rover when we design something.
Okay, another Facebook question. This one's from George Smythe Rumsby. Is it possible that by simply turning the wheels, the rover might dig itself so deep into the ground that it would hit bedrock and then be able to get some traction?
That's a very interesting question because we're wondering about that. The geology in this area may suggest that this loose fine material has sort of been blown in over time and that there may be solid bedrock underneath. But the concern is that if it's too deep, you could sink the wheels all the way in and then put the belly pan of the rover on top of the surface, which we call high centering, and there you would then have no weight on the wheels and you'd never get out.
All right. Equal time again. Now I'm going over to the email questions, and this is from Salvador Trentacosta. I wanted to know if the sensor boom is strong enough to use to lift the rover. That must be the same thing, using the camera arm. Let's go to James Giovanogli. Does the test rover take into account the difference in weight here on Earth and that of the rover on Mars?
That's actually a very interesting question because it's something that we deal with all the time when we're testing. The rover here on Earth weighs more than the rover on Mars because Mars has a lower gravity. It's only about 3/8 the weight, 3/8 the strength of here on Earth. So our rover on Mars weighs about 150 pounds. Here on Earth it weighs over 400 pounds. We gave that consideration when we were doing testing, and we actually have a test rover that's lighter, that's more Mars weight, but we find that it doesn't perform and behave the way we want the rover to work. So we actually deliberately use our heavier rover because it embeds better like the one on Mars. So it's a difference between the soil and the gravity, and those two effects kind of work against each other. And so that's why we're using the heavier rover in this particular soil.
Let's talk a little bit about the soil for a second. The spot that Spirit is in right now, first of all, they call it Troy. Why do they call it Troy?
Well, we have a naming convention for as we explore Mars. We use certain naming themes, whether they're great explorers or different geographic locations. At this location, we're actually using names that are described in Homer's works. So the Iliad and the Odyssey, and Troy was one of those names. And so we've named the site Troy. It's also consistent with the other difficult places that Spirit has had, like Tartarus and Tyrone, which are 2 previous locations where Spirit had trouble. So that's why it's called Troy.
So what if Spirit can't get out of the situation in Troy? What if Spirit is stuck in Troy?
Well, if Spirit truly is stuck, and it would be really, really hard to know for sure if she's stuck, but if she is truly stuck, then we become a lander mission like any other Mars lander mission, and there's a whole suite of science investigations that we would continue to do. Because we have a healthy rover, we can monitor the weather, we can do detailed analysis of the rocks and soils around us, we can do high-resolution panoramas, and they change with the seasons. The terrain changes with the seasons, so we would probably do that for at least a Martian year.
So let's look at this spot. We have a visual. This is where Spirit is right now, and there's the churned up soil. What do you see there?
Yeah, this is a color camera image of the soil right in front of the rover that's been churned up, and you see the traditional Mars red dust soil, sort of the perimeter of the picture, and then you see the light colored material that's been churned up. Now this is a false color image, so we've stretched the colors a little bit, but it does illustrate the difference of the subsurface material. And this is very exciting for the geologists because this material is suggestive of what they call remobilized minerals, meaning that these minerals were emplaced somewhere else, and then some process, perhaps even water, transported them to this location. And there's even some suggestion that this process might have been more recent than the geology around home plate. So maybe there's some recent water action on Mars. And when I say recent, I mean in a geologic scale. We're talking millions of years, perhaps. But that's different from billions of years.
So if water could have carried those elements there, that would be an excellent spot to study.
Oh, it is, and the science team actually wants to stay here. It's almost like we're on a family vacation in our car and we break down next to Disneyland, and so we all go on and spend our time in Disneyland.
All right, well, let's go back to some of the Ustream questions. Here's a new one. How long will Spirit survive and be viable will be a viable asset, I believe, if she never moves again? We're sort of dabbling on this. The fact that this is a good spot, but what about the survival question? How long could Spirit survive there?
Well, Spirit has been blessed recently with the wind blowing dust off the solar rays, and so she has an ample amount of energy, and our estimates right now is that she can survive through the next Martian winter. So that said, this rover could be here for years and years and years, surviving for years more on the surface and continuing to explore. And even if we don't move from this location, long-term monitoring of the weather and the environment on Mars is scientifically very productive and very interesting.
And that's interesting, the fact that the solar arrays have been cleaned off. We've got some images of the dust devils that go through the area, and people can actually see that, that these dust devils
That's right.
help
you see
the
here
rover.
some dust devils in the distance. This is the time of year on Mars, the season in which you get a lot of, it's summertime, the sunlight heats the air close to the ground, it wells up making these dust devils, just like here on Earth. And these things blow through, and they've been blowing the dust off the arrays for Spirit, which is a great benefit to us because it allows the rovers to continue operating on the surface.
So how's Spirit's energy level then?
It's at the highest it's ever been.
Really?
For the rover. In fact, we have too much energy right now, and we actually have to turn things on at night to use up the extra energy.
Well, it's interesting because Spirit has been in binds before, and one of them has been the fact that at one time it couldn't get enough energy because there was too much dust on the solar arrays.
That's right. The last winter, there was so much dust in the arrays, we were only getting about 25% performance out of the arrays. I mean, this rover was so dusty, it was actually camouflaged against the background. And we just made it through the third Martian winter, and we had to be very careful about how we used the energy then. We had to be very miserly. But now we have an abundance of riches in terms of power for Spirit.
So Spirit's very healthy. Can't get out of this bind, but very healthy.
And that's good news for the extraction, because it means when we start to drive the rover out that we can drive for a long time each day, many, many hours.
Okay. Another question, what elements will be added to the test bed? So I guess this question deals with how did you know what to put in that test bed to mimic the situation on Mars?
Well, what we wanted was soil that has very little cohesion, meaning it's very loose, and that it has very little bearing strength, meaning it's pretty soft and things would sink into it, and that it would cling to the wheels. And so we, from prior experience, knew that that was probably a combination of diatomaceous earth and clay. And so that's what this mixture is. It's half diatomaceous earth and half clay. But what we see on Mars is there's a slight difference between the soil on the left side of the rover and the soil on the right side of the rover. And that's important because it looks like we get a little bit more traction on the right side with Spirit. So we want to replicate that in our test bed. And so what we're going to do now is we're going to change out the material on the right side of the rover, on the test rover, and put in some soil that gives it a little bit more traction, and then experiment with that, because that'll be more Mars-like.
How are you able to figure that out? Were you able to use the arm and be able to get a chemical analysis or a spectra of what was there, or did you just sort of eyeball the soil and figure out what that was?
It's mainly from the images we have of the soil, of how the rover is embedded, and how the rover performed when it was last driving. We saw this as the rover was attempting to try to get out of this difficult spot before we stopped. And so that information is mainly what we're using to establish what we do here on the ground. But subsequently, we have been using all the rover instruments to try to analyze the soil, to understand it better. What is its chemical composition, mineralogical composition? But that's more for the science that's very exciting at this site.
Okay, here's another question, and I was going to pull this image, and I should have. It's about this rock touching the underside of Spirit. And the question is the rock touching the rover?
Yes, there is a rock underneath the rover that's touching the underbelly. We suspected this because when we looked at images of the site before the rover drove into it, we knew there was a pile of rocks. And now the rover is on top of the site, dug in, and so our concern was as the rover dug in that it would high center on those rocks. So what we did is we did something we never did before, and this is actually where Opportunity helped us. We first, on Opportunity, used the robotic arm to look underneath the rover and use the camera on the end of the arm. Now this camera is meant as a microscope, so the images are going to be out of focus, but we're still able to see enough detail. And we looked under Spirit, and we did see this rock that was touching the underbelly, just touching in one spot, but the rock looks like it's just sort of sitting or floating on top of the soil. So it's a concern, but right now we don't think it's too much of a complication.
So it's not as though it's wedged on top of it?
No, it certainly looks like it's touching, but it doesn't look like it's bearing any of the rover weight. And the suggestion is that as we try to move Spirit, that rock will kind of move or slide away.
Interesting question. Can you do a tank turn?
Yes, we can, and that's one of the techniques we'll try. That's where the wheels on one side of the rover, we run in the opposite direction from the other side of the rover to turn the rover. And this is something we do normally when we want to maneuver the rover, and that may be a technique that we'll explore.
We should talk about that, and I don't know if there's time to rerun some of the video that we showed from the test bed. What sorts of maneuvers have you tried thus far?
Well, the simplest, most obvious, and the thing we're likely to try first is just to drive straight forward. Because when Spirit got into this trouble, we were driving backwards, so we kind of backed into it. So the obvious thing is to just go back out the way you came in. So that'll be one of the techniques that we'll explore. But because the rover is tilted in the soil, gravity is kind of moving to the left, and so we might try going downslope and to take advantage of gravity to assist us.
So you see here the test bed.
Yeah, you can see here the rover, and you can see how it's buried. The wheels are deeply buried in this material, and we spin the wheels, and you can see you don't get much traction. The rovers are caked, so they don't have, their treads won't have much traction, and they just sink into this stuff. But what we notice in all these tests, the rover moves, although it moves, even if it's moving just a little bit, we'll just do a lot of wheel spinning and eventually take advantage of that to get us out.
And it's interesting. So have you tried, going forward, going backwards, sideways?
Yes, we've pretty much done all the directions to see which one works best and combinations of them. And then we'll do more testing where we have the difference in the soil between the left and the right and repeat some of those.
Another question, can the arm scoop some of the rocks over the tires?
Well, the arm doesn't have a scoop or a way of grabbing things. It's not inconceivable that you could use the arm to push some material in front of or away from some of the wheels. And we've thought about that, and right now it's not very likely, but we'll hold that in our toolkit if we still need to try some things. But we're going to do the more conventional things to begin with because we think those are the ones that are most likely will get the rover out.
We have about 5 minutes more, so let me get through more questions. Don't feel bad if I'm just peppering you with these. Has MRO, Mars Reconnaissance Orbiter, it's an orbiter that takes pictures around Mars, just to let people know, has MRO been able to image Spirit?
Yes, we have a recent picture of Spirit from MRO using the high-rise camera. And the rover only appears as a few pixels in that image, but we do see it at our current location. And we actually can think we see a little bit of this bright soil that's been churned up because the image is quite bright around the rover.
Question, how much potential damage could there be to the underside of the rover from this rock and from the rover moving over this rock?
Well, when the rovers were designed, one of the things we were worried about is climbing off our lander that would bring us safely to the surface. And there was always the risk that some piece of hardware on the lander might scrape the underbelly of the rover as it's driving off onto Mars. So when they built the rover, they kind of armored the underside of it, and there's about an inch of clearance between the outer skin of the rover and any of the sensitive internals. So we're not so concerned that something underneath would damage the rover.
Here's an interesting one. Would driving at night or driving in winter help?
That's an interesting question, whether temperature affects any of the physical properties of the soil. I would say right now that because we've churned everything up so much, it probably doesn't have an effect. But we still think about those kinds of possibilities.
Could you retract any of the wheels to the original stowed position? You know, it landed on Mars sort of like a little origami, all folded up, and then it unfolded itself. Would it still be able to do that?
No, the deployments that we had on landing are all single deployments, and the rover wheels, when they deploy, latch into place. So there's no way to unlatch them and fold them up. So we're stuck with the rover in its configuration.
All right, we have 3 minutes left. Here's a question. It was an emailed question, and I love this one, from Wen. Why not send Opportunity to the rescue?
Well, Opportunity is a long way away. It's completely on the other side of the planet, 12 Martian time zones away. And so it would take a lot of driving to ever get there. It's not possible, I'm afraid.
Can the arm slightly tap the soil in front of the wheels? Does the arm have access to all the wheels?
The arm can't reach all the wheels, but it could reach the 2 front wheels. And that's something that we could consider down the road if we're unsuccessful with extracting the rover.
Because someone else here on Ustream asked, could you scoop the wheels to move the dirt? Could you scoop away some of the dirt using the arm or pushing?
Well, we could, but it's you know, unlike having your car stuck in snow or mud, it's not so much affected by the loose material that's in front of the wheels. It's really more about what's directly under the wheel and how much traction the wheels will have on that material.
Would NASA be willing to sacrifice the arm to free spirit? I'm not sure how that could actually free spirit if you sacrifice the arm.
Well, some people, we've gotten suggestions from the public of, why don't you just take the arm and wedge it under a wheel and use the wheel to drive over it to give you traction, and that might damage the end of the arm. Again, those are some of the exotic things that, of course, we think about, but we're a long way from that. We think that the best thing to do is to drive the rover as we have been driving, but it's just going to take a long time. I mean, it's going to take, once we start driving, many, many weeks before we get out. It's going to be a slow process no matter what.
Well, we're just about done with our time, so what's next then? When do you foresee us really trying some of these maneuvers on Mars?
Well, we have about another week of testing. First, we have to make the change to our test bed, which we will do this week and part of next week. And then we will do these set of new tests that we want to do with a different material. And so we're targeting maybe towards the end of the first week of August would be when we try things for real on Mars.
And no worries about Martian winter coming and jeopardizing things, or?
No, we're fortunate because the solar arrays were cleaned off that we have almost all the time in the world, or all the time on Mars, to get Spirit out. So we're taking our time, and we're doing due diligence here to explore all the possibilities here on the ground before we do them for real with the rover.
Well, John, thank you for joining us. As you can see, there's a tremendous following for these rovers, tremendous affection, and we have lots more questions. We'll shift things now over to Ashley Stroupe, but before we go, we're going to run our latest edition of the Free Spirit Update. We do these every week, so if you stay and go to our website, www.jpl.nasa.gov. You can see our updates every week. They're video updates from the test bed. Let's go to our most recent one from Ashley Stroupe. Here it is.
Ashley Stroupe, and I'm one of the rover drivers here at the Jet Propulsion Laboratory, and I'm here with the latest Free Spirit update. This week we're continuing crab driving testing. That means we're steering the wheels to different angles and trying to get the rover to move sideways along the hill. We've done some testing both with forward crabbing, and now we're doing backward crabbing, and we've now got the wheels steered to several different angles. The test you can see behind me, we've got the wheels all steered to 20 degrees and they're all driving backwards to try to pull the rover backward and uphill away from these potential obstacles that we seem to have run into in our first attempt to get out of the sand trap. We break each test into several smaller pieces so that we can measure the rover's progress along the way. That way we can tell whether the rover is making steady progress throughout the test or whether it may come up against a wall and only make good progress at the beginning, in which case then we know that extra wheel turns are not going to make much of a difference. One of the great things that's happened along with Spirit sitting still for so long is, of course, we've been parked in a really windy location, and the winds have come along and cleaned off the solar panels tremendously. So now we have lots of power, which not only gives us many hours a day where we can conduct scientific experiments and do our mobility tests on Mars to try to get the rover out, but we've bought ourselves a lot more time before Spirit will even have to consider parking for the next Martian winter. So I'm Ashley Stroupe, and this was your Free Spirit update.
All right, with us now is Ashley Stroupe. She's one of our rover drivers, and lots of people have no idea how these rovers are operated on Mars. Spirit and Opportunity, you're not driving them with a joystick and, okay, avoid that rock, you actually have to program it. So before we go any further, let's just explain to folks exactly what a rover driver does.
Sure. Well, it is like driving a car with a computer program. So every day we have to sit down and look at the images of the world around us and figure out where the rover is going to go. And then we have to build a program essentially that will guide the rover along that desired path.
Let's go to the video and you can show folks.
I can show some examples.
Let's go to the videotape. And this is the rover driving. So you are in a room, essentially.
Right. We sit in a room at a computer terminal where we can pull up all of the images. Here you can see two of my colleagues evaluating some terrain from Opportunity. And they're looking at the potential hazards. They're looking for any rocks, any hills, any loose soil that they would want to avoid driving into. We can also look at these images in 3D. And so we can see Mars the way the rover would see it or the way we would see it if we were there, so we can get a better of assessment. There you can actually see the 3D glasses that we use to be able to look at the terrain and predict what rocks are dangerous and what rocks are safe to go over. And we also have tools where we can measure things in the image using the stereo models that the rover has built for us. So we can see if there are any rocks that are dangerous for the rover to drive over. And then once we've assembled the plan of what we wanted to do, we sit down and we write the program and build the sequence of commands. And then we simulate those commands. We play them back in a full model of the rover and the terrain so we can see how the rover is going to interact with the terrain. And we do that both for driving or, as you can see in the video, this is an example of testing out the robotic arm, the IDD, and a sequence of commands for placing an instrument.
How involved is that? Do you meet once a day and figure out the marching orders for the rovers every day, or what?
Right, so pretty much once a day we sit down with all the engineers and all the scientists and we come up with the general plan of what the robot's going to do for that day, where it's going to drive, or what targets it's going to look at with its science instruments. And then each sub-team goes off and builds their part of the program, and then we come back together and we walk through every line of the program that's going to go up to the rover twice before we then send it to the rover on Mars. So we then send the plan up, the rover then executes the plan, and then at the end of the day, she calls back home and lets us know how everything went. So we have to often wait a long time before we know how things went on Mars.
And what's involved in the planning? Isn't it mostly scientists saying, boy, that rock over there to the right really looks interesting. Could you get us over there?
Right. We are a science mission. As exciting as the engineering is, we really are a science mission. So it all begins with what the scientists sit down and they say, this is what we want to do. Here are the interesting things around here, and we want to go look at these things. And then we try to evaluate all of those different places they want to go, and hopefully we can accommodate all of them, but sometimes something might be too dangerous or too difficult to reach, and we have to tell them, well, we can't quite do that, how about this? And so there's a little bit of negotiation going on. But we do start with the science first, and we really try to get the scientists what they need, because ultimately that's what we're trying to do.
Well, the purpose of our talk today is figuring out ways to free spirit.
Right.
And here we have a suggestion here from someone on Ustream. Why don't you use a harness to make the test rover weigh the same on Mars? Do you really need to do that, though?
Well, sometimes we do have to do testing, and in fact, you know, when we're first building a robot, we often do that kind of testing to exactly simulate what Mars gravity would have. But our test rover is actually lighter weight than the one on Mars, so it's not quite down to Mars gravity, but it's part of the way there. And actually, that is a close enough model for the kinds of things we're trying to do. Actually, the rover being a little bit heavier actually makes driving in this stuff a little bit harder. So we're sort of modeling the worst case, if you like, by letting the rover be a little bit too heavy for Mars.
I think a lot of people are learning about that for the first time, that we have two different rovers. There's a test rover that's the same weight as the rover on Mars.
Almost the same weight. It's missing some of the batteries and the solar panels and some of the other heavy components, but it's very close to the weight of the rover on Mars.
And I'm not sure very many people realize that there's a difference in having to factor in gravity.
That's right. Of course, the gravity of Mars is a little under 40% that of Earth, so things weigh about a third there that they do on Earth. And of course, how you interact with the ground is very dependent on your weight. So sometimes you really do need to take that into account when you're modeling things.
All right. We're going to some of the email questions now.
Great.
This one's from Mark Parker. Could the denser material be placed under one wheel at a time on the soft side to raise that side enough to clear the object underneath?
You know, that's a good suggestion. A lot of people have been thinking about that kind of thing, but unfortunately we don't have any way to transport material under the wheels. The arm could only reach the front wheels anyway, but it also isn't really strong enough to move large amounts of material. Particularly, we'd also be at risk of damaging some of the science instruments if we actually tried to interact with the ground in that way. So unfortunately, we don't have a good way to actually change the soil or add rocks or add more soil with traction underneath the left side.
Okay, this one's from Roger Silber. Does the rover instrument arm have enough strength to provide a useful force vector to free the rover?
Unfortunately not. The arm can only exert about 15 to 20 pounds of force. It really can't do anything approximating lifting the rover or move any large rocks or anything like that. It's really only designed to just sort of gently contact the ground. It was never designed to actually really exert much force.
How much force could the arm exert if used in such an emergency sort of push assist scenario?
Right, probably only about 20 pounds of force. So in a real emergency, we might give it a try. That might be the little bit of a difference that we need. But because that is such a risk to possibly damaging the arm, that's a long way off before we try that. But you know, as a last-ditch effort, we might give something like that a try, but it won't be much of a help, just a little.
Okay. This is an email question from Lee Wilkerson. The current position of the Spirit rover shows the right wheels on what appears to be a firm surface, with the left wheels mired in the soft soil layer. However, the rover in the test sandbox has all wheels embedded in the soft soil. Why was this scenario chosen for the simulation?
That's a really good question. So the particular simulant that we picked has some interesting material properties. If you pack it down tightly, it actually stays kind of firm and strong. But if you fluff it up, then it becomes loose and fluffy, like what we see under the left side. And we had really hoped that we'd be able to use one material, compact it differently, and have that work for both of the different types of soils we see on Mars. Right now, in fact, today, we're having a big meeting with the engineers and the scientists to look at the tests that we've already done and see if that assumption holds up. We are seeing some differences, and as a result of that, we may likely change that soil that's under the right wheels. So excellent question, and we may be changing that for our next set of tests.
Well, here's another question regarding opportunity. Can opportunity help? And what is opportunity doing? And we have some video to show.
Great question. So opportunity is unfortunately on the complete opposite side of the planet. And given that they, have driven at most about 10 miles in 5.5 years, they probably will never meet each other. So unfortunately, opportunity can't help. But opportunity, we've now got a video up that's showing basically opportunity's entire 10-mile plus trek. She started at a little tiny crater called Eagle and then visited a larger crater called Endurance, and then drove several miles across some sandy plains to hit Erebus, which you're just about to see the video catch up there, and then headed off to a really large crater called Victoria, which we spent about a year exploring Victoria. And now we're actually heading towards the south, towards about a huge crater that's miles across called Endeavour. And that is Opportunity's next goal. We're really hoping, this is a very old crater, it's very deep, but it's very eroded, so the sides are gentle slopes. So we're hoping we can drive deeply into that crater and see some really old layers that are exposed nowhere else that the rovers have been.
Did anyone ever imagine that Opportunity would be going that far?
No, I don't think anybody imagined that. Certainly we all sort of hoped and even maybe a little expected that we'd go far beyond our 300-meter design guideline. But in terms of 10 plus miles, no, I don't think that was in anybody's wildest dreams. But we long since gave up trying to bet on when it would end, because if you bet against the rovers, you're just going to lose. They just keep going.
But I guess we have to keep in mind that the rovers are getting older.
The rovers are getting older. They each have some faulty joints now. Spirit has a broken right front drive wheel, but Opportunity also has a steering motor on the right front wheel that's broken, and one of the shoulder joints is also broken. Now, gratefully, these have not done anything other than slightly slow them down. They certainly are still able to do much of their normal capabilities. But they are aging. We're sort of creating a new field, robot gerontology, because robots on Earth, when this happens, you just fix them. This is the first time we've ever been in an experience where we've had to continue operations with continually changing performance and degradation over this many years.
Well, the subject of opportunity keeps coming up, and they're asking, can opportunity help? Well, opportunity has helped.
Well, actually, yes, Opportunity did help. We wanted to do something a little bit risky with Spirit to help diagnose her situation. We wanted to take out the robotic arm and take a picture underneath the rover's belly so we could see the middle wheels, which we normally can't see how buried they were, see if there were rocks hung up on the rover. And because we were in some very complicated geometry, we didn't want to pull Spirit's arm out if we didn't think that this would actually be helpful. There was a risk of hitting it against a rock. So Opportunity actually did that first. We had Opportunity deploy her arm and take a picture underneath herself, and we got fabulous results. We could really see a lot of detail. So after we knew that it was going to be a worthwhile pursuit, we then figured out how to get the arm safely out and did take a picture, which has told us a lot. We in fact do have a rock that may well be touching the bottom of Spirit. We can see how buried the middle wheels are, which we couldn't see any other way. And so that has really helped our diagnostic problem.
And will Opportunity be called upon again in the future, do you think?
If there's another risky thing that we have to do, we may test it on Opportunity first, because Opportunity is in a much more benign terrain. It's much safer for her to try out new and different things. So certainly that could happen.
All right, so here's another question, another suggestion from our viewers. What about using very slow wheels continuously? Would that help get out of this soil?
That is an excellent question. That is one of the things we are considering. If you slow down the wheels, you might be able to get slightly better traction. If you're spinning fast, you're more likely to slip. And so that is certainly one of the things that in the next round of testing we are considering looking at. We don't know yet how well that will work, but that is an excellent suggestion, and we are thinking about giving that a try.
So how has the testing been going? Are you seeing certain things working, certain things not working at all?
Right. So we've done a bunch of testing. we've done forward driving, backward driving. We've done even some sort of sidewards crab driving, as we saw in the video a little while ago. And we are seeing the good news is, even though we think this is sort of a worst case model with really slippery soil and the wheels buried a little bit more than they are on Mars, we are seeing that the rover is able to move at least a little bit, even under these very adverse conditions. And so that has told us that we actually do have a good chance of Spirit being able to get out once we start this on Mars. At the moment, it looks like that we don't have quite enough data to really distinguish which individual things are going to be the best, but all of the things we've tried have moved the rover a little bit. We're very optimistic about this idea of possibly being able to crab and go slightly uphill. We do have, unfortunately, we'd like to rely on gravity in these situations, but downhill from us is an even worse sand pit than the one we're in. So if we could get uphill and away from these possible hazards, that would be a really good thing. So that's one of the things that we're definitely going to be looking at as well.
And once again, explain crabbing. It's
right,
going
so crabbing, so only the front and rear wheels on the rover steer. But what we can do is we can steer those wheels at an angle and then drive them forward, and they're all driving in the same direction, which kind of pulls the rover to the side a little bit. And we have used that before to try to approach science targets when they were off to the side of us a little, and it has worked very well. And in fact, we were using that to try to get us out of the sand pit originally before we realized we had these other potential hazards and needed to stop and reevaluate. And that was actually working somewhat. We were moving several centimeters each day. So.
Is there any similarity between what's happening to Spirit right now and what happened to Opportunity way back when it was going through the dunes?
Sure. Purgatory ripple is what you're talking about. Opportunity got fairly deeply embedded in a sand ripple. And yes, there are some similarities. The soil there was a little bit fluffy. We did get the wheels buried in very deep, and we had very little traction. We would try to drive a long distance, and we'd only move a few millimeters. So in some ways, the soil that we're in is kind of similar. The difference is that Opportunity was going uphill over a ripple and could then kind of use gravity to back straight down the hill through her tracks. We, unfortunately, Spirit's at a roll, so we to follow out our tracks, we don't get that extra little advantage of gravity helping to pull us down the hill. So we have a slightly more complicated geometry, but a similar problem.
Is Spirit more dug in, though, also?
Actually, Opportunity was pretty much as deeply dug in at Purgatory. Part of the problem was Opportunity drove about 40 or 50 meters before before she realized that she was slipping, because she wasn't looking where she was going at that point. That's very common to do when there are no obstacles around. We just let the rover drive in what we think is a safe area. So it continued to spin the wheels after she stopped making progress for a long time, and it actually dug in quite significantly. So the rear wheels and the middle wheels were about as dug in as what we've seen on Spirit, but the front wheels were not as bad.
Something that lots of folks aren't familiar with is the fact that the rovers do kind of operate on its own with their own brains and autonomously. Were they operating autonomously? Was Spirit doing that?
Yes, in fact, so Spirit we had given her a path to follow, and she was autonomously trying to follow that path, and in fact slipped off that path to some extent and stopped the drive as a result of failing one of the own safety checks that she had in there. She realized she was off course and stopped. So yes, she was driving autonomously when this happened.
They have their own intelligence.
That prevented it from getting even further embedded and perhaps into a much worse situation.
Okay, back to the questions. Can the science team conduct tests while you all attempt to help Spirit escape?
Yes, we have been doing a very extensive science campaign while we have been sitting in this location. We have tons of power thanks to the wind cleaning everything off. So we've been doing all kinds of science experiments. We have at least 4 different soil types that we can reach with the robotic arm, and we have done detailed analyses of all 4 of these soil types. We're continuing some further investigations today. In fact, we have brushed away the surface soil in one location, and we've actually gone down and seen that the soil changes like about 1 centimeter down. So we're actually investigating to see what that slightly deeper soil is. And we've learned that this soil is a little bit different than what we have seen elsewhere on Mars. It has a lot of sulfur in it, a little bit of silica, and I'm sure a scientist could tell you better what makes that unique, but it's a very interesting discovery that we have not seen anywhere else on Mars.
And any signature that would lend you to believe that water may be involved in any of this?
Absolutely. Whenever we find many of these mineral compounds, many of them are the result of water transporting these minerals to these locations and then evaporating away. And we've seen that at many locations all around home plate. And in fact, this is an interesting thing, is that we wouldn't have found nearly as much of this stuff and known it was nearly this widely distributed without the broken right front wheel, because it's mostly buried under the surface. And only by digging a hole, which the right front wheel does for us naturally most of the time, we've been finding these mineral deposits and salt in our tracks almost everywhere we go.
That's interesting, because here's another question. What have you learned from this set of difficulties in the design of new rovers? What have you learned that will help you design the next rover?
Right, that's an excellent question. And I know one thing that I would like to see on a future rover would be able to steer those middle wheels. If we could steer those middle wheels and have all the wheels help pull us sideways out of this stuff, that would be a nice thing that we could do. That would certainly be a big help right about now. Other than that, I can't possibly imagine what we could do to improve these rovers. They've lasted 5.5 years when they were designed for 3 months. They've been able to climb slopes much steeper than they were supposed to be able to climb. They've been able to cross sand dunes, which they were never designed to climb over. They've withstood massive sandstorms and been cleaned off. The people who designed and built this rover, many of whom are friends of mine and colleagues of mine, they did an amazing job. I can't really imagine what else we could do to improve them. They're fabulous machines.
Would they ever consider putting, say, like a hoe that would drag behind and dig soil up, just like this broken wheel would?
Well, in fact, the next rover, the Mars Science Laboratory, is actually specifically designed to be able to core down even deeper than we can dig with Spirit's wheels and look at what's underneath the soil. So yes, in fact, we have learned how important it is to be able to get down below the surface. Phoenix, our recent lander mission, was designed to be able to dig down, as is the Mars Science Laboratory.
Okay, here's a question. Why worry about damaging the science instruments on the arm if the rover would otherwise be stuck?
Well, you know, that's a good question. I mean, the real answer is we are a science mission, and if we can't continue to fulfill our science objectives by taking measurements and analyzing rocks and soil, then you really have to ask yourself, is it worth driving somewhere new when you can't do much other than take pictures? So I don't know, and that's certainly a question well above my pay grade. You know, if it comes to that, I'm sure somebody else will be making that call. But I certainly hope it doesn't come to that.
All right, well, we only have about 5 minutes left, so I'll try to go through a few more questions a little bit more quickly. Wasn't there some indication of the soil change through wheel resistance? And why wasn't Spirit stopped as it entered the soil?
Actually, there was no significant difference we looked very carefully at the currents on the wheels and all of this after we drove into the spot, and there was no obvious change in the telemetry that we could monitor. Unfortunately, because the resistance of the soil went down, but there were big piles of it around there, we're not getting a lot of traction, but the wheels are still experiencing some resistance. So that, unfortunately, we couldn't really measure that autonomously on board. But it did notice that it was slipping and off course, and it stopped for that reason.
Can all the wheels be turned independently? Well, you sort of...
Right, so the 4 steerable wheels can absolutely be turned completely independently, and all 6 can be driven independently.
But one of the 4 that could be moved independently is stuck, is it not?
Right, well, it can steer, it just can't drive, yeah.
Ah, okay, all right. And the rest of the question, so doesn't that give you a huge range of motions to try to get out other than forward and backward?
Well, and we have done a lot more than forward and backward. We have steered the wheels to the right at a couple of different angles and tried to climb uphill. We've steered the wheels to the left and tried to climb downhill. We've done the reverse, going backwards, doing that same thing, both trying to climb uphill and downhill. And we've even steered the wheels in a circle around the right front wheel, which kind of can act as an anchor in an attempt to try to pivot around that wheel and see if we can move the rover that way. And all of these things have shown some amount of motion. So there is potential that any of these things might be able to help us. And in fact, we are going to be discussing that today and tomorrow. We're going to look at all of our data and figure out exactly what the next things we want to test are.
All right. How about turning the wheels somewhere around 90 degrees from the front back axis of the rover and trying to go out sideways?
Right. Well, the wheels can only steer to about 60 degrees, so we can't quite get to 90. But we have done that testing, and that testing actually looks very promising. And right now, at least that's on my personal short list of things that I would like to be trying on Mars. Because, yeah, that can help us not only climb uphill away from the sand pit, it might help pull the left wheels out of the fluffy stuff and onto the firmer stuff that we see on the right side. So, yes, that is a very good idea, and that is certainly on my short list of things to do.
Here's a little bit more of a personal question, and we get this all the time. How does one get a job as a rover driver?
Well, me personally, I came to JPL right before we landed and never had any hopes of being able to work on this mission. It was supposed to be long over before anybody would let me anywhere close to flight equipment. But they lasted so long and were doing so well, they had to start hiring new people. And I'm a PhD in robotics. Robots are what I do. And I have to say there's a little bit of luck involved. My boss at the time was doing the rover driver job. And so he recommended me as one of the new people to come in and start training.
And where does one major in robotics?
Well, there are two places in the country right now that offer PhDs in robotics. One is Carnegie Mellon, which is where I went, and the other is Georgia Tech. But a lot of places, either in the mechanical or electrical or computer science department, have a lot of robotics researchers. So there are lots of places you can go and study robotics.
Here's another one. This is cute. Has NASA considered contracting some dune buggy drivers and racers for their suggestions?
Well, we have certainly solicited, suggestions from anybody out there who wants to listen. Unfortunately, what the dune buggy drivers have that we don't is acceleration. These rovers go at something like 1/20th of a mile an hour, and you just can't build up any momentum like you would like to do when you're in one of these stuck situations.
You can't gun it and muscle through.
You can't gun it. Gunning it is very, very slow.
Can Spirit survive the winter?
Right now, we've gotten the solar panels nearly completely clean, and right now it looks like if nothing significantly changes, if we don't have another major dust storm, that Spirit will be able to survive the winter and probably won't even have to park.
Great. In the simulator, have you tried to back out?
We have tried going both backwards and forwards. The difficulty with going backwards on Mars is actually not too far behind the rover, which is almost level. The slope significantly increases. So we'd actually, before we go too far, we'd actually be climbing uphill. So we might try to back up a little bit to get away from whatever hazards might be around the wheels and then go forward again. But yes, we have been driving forward, backward, uphill, downhill, everything we can reasonably get the vehicle to do.
All right, well, we've reached the top of the hour, but one more question. What's the time frame for trying all these great ideas on Spirit?
Well, we want to try these combinations of maneuvers first to see if there's any set of motions that seem to really be able to pull the rover out of this, and we may be doing that in a slightly different soil simulant. But we're hoping possibly as early as the end of the week of August 3rd. So toward the beginning to middle of August is when we really think we'll be starting to work on Mars again.
So we may be trying this out in just a few weeks.
Just a few weeks.
Wow.
And it's not soon enough. Spirit is ready to go.
Well, good luck to you. And thanks for
you.
joining us. And thanks for joining us in the Cosmic Lounge here at the Jet Propulsion Laboratory in Pasadena, California. If you do wish to get updates, just go to our website, www.jpl.nasa.gov. Sign up to some of our feeds. And also Twitter, Facebook, Ustream, they're all there. Thanks for joining us. We'll see you next time.